Feeling better, Josh?
A lot better, yeah.
So you did test positive for COVID-19.
Yeah, I
But you had
had.
a really mild case.
Yeah, it wasn't bad.
Yeah. Power of vaccination. Addie, how you feeling?
I'm feeling okay. Last night was kind of rough, but yeah.
You look like you could use a bit more sleep.
Yeah.
Your quarantine, both of you, ends when?
Mine ends Friday.
And Eddie?
Friday.
Friday, okay. So
Our final exam's Friday, right?
yeah, and
8 to 10 or something.
something like that, yeah. We can do the final over Zoom if that works for you guys. I'm okay with that.
Okay. I think I'll already be back for Dr. Baldwin is having me take 2 exams that day. So I'll
All right.
already be back if you just want me to take it there.
Do that. Since you're feeling fine, that would work. Well, Addie, let's see how you do. If you're feeling better and you feel like you want to get in the saddle and come to class, that's fine. If not, I'm flexible.
Okay. I live kind of far from campus. I live near Grand Rapids. So
You're home now?
yeah, I'm at home.
Oh, okay. So coming in would be an imposition, shall we say?
Yeah.
All right, we'll do it by Zoom. That's fine. Where's Josh? You're still on campus?
I'm not, but I only live like 15 minutes away.
Okay. All right. And we have a skeleton crew today. Probably because it's still so darn cold in here. Just be thankful. And you guys are in your warm rooms because it's not so warm in here. Oh, and Carly's joined us. Hi, Carly. Carly, can you hear me all right?
Yeah, I can hear you.
Okay. Are you home too?
Yeah, I haven't been feeling well. My rapid test came back negative, but I'm still waiting for the other test.
PCR test. Okay. All right. Then we'll do this. Well, the way I do review sessions is I don't plan anything. I don't prepare anything. You guys hopefully have questions. And please don't ask me what's on the test because I haven't written it yet. So I have plenty to do before now and then. I am started to get caught up on the grading because last night at midnight, I finished this big editing project. Hooray for me. Now I've got to catch up on all the grading. So that's happening. So you should see some grades popping in as time goes on. But for now, let's see what kind of questions you guys have. So who has a question? Anyone? That includes you guys on Zoom as well. Shocked silence.
For the time periods,
Yeah.
should we like how much do we need to know there? Just what some main events of what happens in those and
I want you to know the time periods and their years.
and the order.
Roughly. Their years roughly. And so for example, if you say the Cambrian started at 450 million years ago as a nice round figure, that's fine. I don't need you to know 443. If you say 250, that's fine with me. But if you, for example, if you say the Cenozoic started 280 million years ago, you're wrong. So you should know that the Cenozoic started when the dinosaurs died out 65 million years ago. If for a rough number, if you say 60 or 70, that's fine. But you need to essentially be able to tell me with rough numbers, essentially, when the time periods are, because I will ask you about specific time periods. So if you say the Cenozoic was the age of dinosaurs, you're wrong. If you say the Mesozoic was the age of mammals, you're wrong. If you say flowering plants appear in the Precambrian, you're wrong. So you should know essentially what comes up where and about roughly the time periods when they appear. Now, keep in mind, when things appear in the fossil record is when we have actual evidence that they appeared. They may have been alive earlier. So when you say, for example, that the first land plants appear in the Silurian, there may have been land plants around a lot earlier than that we just don't have record of. So the first objective evidence of land plants is in the Silurian. So were there any in the Cambrian? Might have been. We don't know. Molecular data says there probably was, but we don't have record of them. So bryozoans, the earliest bryozoans for years were from the Devonian. Just recently, bryozoan fossils were found very early. So that attests essentially to the primitive nature of both genetically and morphologically of the bryozoans. So people were pretty confident bryozoans existed earlier in the fossils, but bryozoans, mosses, they don't fossilize very well. So do keep in mind that caveat when you're looking at dates of things that first appear in the fossil record. Also, we talked about this earlier, some ages have very good fossil records, some don't. It's just due to the nature of fossilization. So there are certain periods where your fossil record is terrible. So certain transitional forms and what have you, it's difficult to find them because some periods don't have good fossils. The early Cambrian, the Burgess Shale and Xinjiang and so on and so forth, amazingly good fossil records, extremely good fossil records. When you get a little later in the Silurian, middle Silurian is pretty good, early late Silurian is pretty crummy. So it depends on the times and the conditions for fossilization and so on and so forth. Next question. Randy, I see something percolating.
Just a quick list of the eras between the Precambrian and Cenozoic.
Precambrian and the Cenozoic, you need essentially to know the main periods. I'm not so convinced with the ages. I want you to know the periods. So from the Precambrian, the Cambrian, the Ordovician, the Silurian, Devonian. The Carboniferous gets broken into the Pennsylvania, Mississippian. I'm not so concerned with that one, just more Carboniferous. Permian is very, very important. Remember the Permian, you get the fusion of the major land masses into Pangea. And then the Mesozoic starts after a major extinction event at the end of the Permian. And then the Triassic starts, you have Pangea, the world is probably very dry. There's probably a lot of desert. You probably have a wet season and then a very long dry season. So you are selecting for organisms that can store water, that have very efficient kidneys, that make very concentrated urine. You're selecting also for skin that doesn't lose water very quickly. And the best source of food at this time, because the plants are kind of scrubby and don't have a lot of nutrition, is either animals that burrow and eat tubers and things like that, because those have lots of nutrition and water, or meat. So that's why a lot of your big specializations for carnivory come online essentially at this time, and those are your dinosaurs, of course. And the dinosaurs ruled the earth all the way into the Jurassic, the Cretaceous. And then at the end of the Cretaceous, the KT boundary is the meteor strike. And then the dinosaurs kick the bucket. Mammals seem to survive. Mammals burrow, mammals hide in small places. Mammals are small. They have a higher metabolism, but they don't need, the big meals that the big dinosaurs need. And the mammals, by hook or by crook, survive. So do the birds. And so into the Cenozoic, early on, the mammals are still pretty small. Your birds some of them get bigger and flightless and become highly predatory, but the mammals really take over. The reptiles then start to get small, and it's your lizards. And the archosaurs still survive in the form of birds and crocodilians. Crocodilians, however, diverged from dinosaurs very early. You have crocodiles, big crocodiles, all the way. In fact, crocodiles, the early crocodiles, the so-called panzercrocs, were actually animals that walked on two legs. And then as they started to get more top heavy, they started to walk on four legs, and then they were pretty much restricted to, they were just too slow moving to compete with fast moving bipedal critters. And they retreated more to water environments where they could hide and attack by stealth and so on and so forth, which they still do today. So then in the Cenozoic, Paleocene, and then the Eocene, the Oligocene, the Miocene, and then the Pleistocene. And then today we're thought to be in the Holocene. And then the rough time periods essentially that mark those off. So the Triassic period essentially starts about 250-ish million years ago. That's very rough. I'll call it 260. So the Permian pretty much goes from 300 to about 260. And then that goes, the Mesozoic goes all the way from about 260 to 65 million years ago. So the Mesozoic is almost 200 million years worth of geologic time. Precambrian, you've got a lot of stuff going on, but our fossil record is terrible, except for the Vendian right before the start of the Cambrian. So those are the geologic, that's a geologic time scale. We talked about it. So in order to say this is going on at this period of time, you need to know what to call that period of time. That's why I want you to be able to know the geologic time periods. Other questions?
I have a question.
Yeah, go ahead.
So for like all the different types of like human species that we went through, what like things should we know about them? Like where they were found, like how old they are, like that type of stuff?
Well, where they're found is largely on the African continent. It's only when you start getting into the later species, they start to move out of Africa. The big traveler is Homo erectus, and then the Densovians also have been found all over Asia, so they're travelers too. The anatomically modern humans, they appear first either in Africa or very close to Africa. So they appear in Israel, they appear in very, very southern Europe. So they're leaving Africa really usually only later, about 50,000 years ago, frankly, So, and genetically, it's very clear that when you look at human diversity, people essentially whose descendants come from the African continent have far more genetic diversity than all other humans. And all other human diversity is a subset of this broader diversity that's on the African continent. So it's very clear that anatomically modern humans have their birthplace in Africa and in northern and eastern Africa. So in terms of where they're found, at Olduvai Gorge or so on and so forth, I don't need you to know that. Just the material that is used to type a species. I told you where they're found because they're named typically after where they're found. So OH, whatever, that's Olduvai humanoid, because it's found at Olduvai Gorge. Whereas the STW, that's Stong Fairkind, that's in South Africa. So that's just the reason why I told you where they were found. Most of them are found in Africa, except for your later species that start to move out of Africa. So that would be Homo heidelbergensis and Homo ergaster, Homo erectus, and then of course Neanderthals. Neanderthals are largely cold adapted offshoots of the erectus, ergaster, that lineage. And humans in their genomes have Neanderthal DNA. So it's clear that there was interbreeding between those two groups. Anatomically modern humans interbred with Densovians too, especially in Asia, because there's Densovian genes in the human genome too. So I guess you could say genetically modern humans are a bit of a checkered past, I guess you could say to some extent. That's kind of a strange way to put it, but a mixed past, shall we say. We have contributions from several lineages. So the Neanderthals are found in Israel and in Europe. They're not found outside those two places. Neanderthal-looking Homo erectus species are found in Northern Africa. They're not really found outside of that. And then modern humans, of course, are found all over the place. So modern humans diverged extensively. So if you were concerned, Addie, about where certain finds occurred, or the name of the person, was it Johansson, was it Leakey, was it, nah, I don't need to know that. Just the fossil, just the fossil. The fossil is really what's important and what's interesting too. I would like you to know their rough time period. So for example, Sahelanthropus is that early or late? I can't hear you, Addie, you're muted.
I don't know.
Sahelanthropus is early, really early. That's about 8 million years ago or so. So that one's very early. When you get into the Australopithecines, now you're getting into the 4 to 2 million to 1.8 million range. And then the Homo species, Homo habilis being the first one, they start. Homo habilis, Homo rudolfensis, they go from about 2.2, 1.8 up until when Homo erectus dies out, probably close to 800,000 years ago, more or less. So if you notice, Addie, I'm ballparking figures. I'm not trying to be really, really, really exact about figures. Go ahead and ballpark figures. If you say Homo erectus, about 5 million years ago to 1 or 2 million years ago, I'm fine with that. If you say Homo erectus existed 10 million years ago, that's wrong. That's wrong. You say 5 to 2, I'm fine with that. You're in the ballpark. So
And will those be like you write in your answers?
the test will be multiple choice, Kylie. Test will be multiple choice. I saw this huge look of relief on Addie's face when I said that. Everyone hear that question? Yeah, test will be multiple choice. There'll be one small short essay at the end, which I've already told you what it will be. So I'm looking at, 50 questions. So you guys have plenty of time. Plenty of time. Other questions? Sam, Luke?
I have a question about the bird evolution and whale evolution.
Yeah.
Do we need to know specific fossils and order of them evolving? Or can
Yeah,
we
the
just-
fossils that are significant are the ones that have significant anatomical changes. So the Confucia ornis is a really important fossil for birds because that's the one where you take the tail and you fuse it into the pygostyle. That pygostyle is really important as a rudder for flight, for maneuverability in flight so that you're not just gliding, it's actually powered flight that you can actually turn effectively without slamming your head into a tree. So the particular fossil and the anatomical modification that's significant, that's the part that I'd like you to know.
Do we need to know like the order they come into?
You should know roughly about the time that the fossil's found. Bird fossils too are strange because some fossils show interesting modifications, but they're found later. But there's pretty good reason to suspect that they were alive earlier. So the timeline of bird evolution still is a little bit topsy-turvy in some ways, but the modifications are there in the fossil record and they appear within time ranges that are pretty good approximations of each other. And you can see that no one character, the bird essentially gets things gradually. They get, the tail and they get the wrist that locks and they get the claws start to recede on the fingers and the teeth start to recede from the premaxilla and then the maxilla. And then they start to, the fingers get fused and then as the fingers fuse, the toes fuse as well into a tarsometatarsus and a carpometacarpus. And then the shoulder, you get a strut-like shoulder. So you limit the movement of the shoulder. That essentially gives you the ability essentially to do the flapping motion. You also start to get modification to the chest where the sternum now becomes the keel. You can attach those flight muscles. You get the really powerful downstroke that helps you lift off. The foot then you start to get the perching sort of anatomy for perching so that you're not so much for walking, running, it's more for perching. Each of those things happened in different species and allowed essentially for different abilities of powered flight. Because the early flyers, we looked at Archaeopteryx. Archaeopteryx was not a strong flyer. There's no way, given its anatomy, it was a strong flyer. It's probably a glider that could flap, but could not sustain flight for long periods of time. That's okay. If you can glide essentially and get away from things or get to things, that's an advantage, isn't it? That's a big advantage. And there are lots of dinosaurs that have been found now that were feathered, that were probably not good flyers, they were gliders at best. Also, again, keep in mind, you don't need feathers just for flight. Ever worn a down coat? They're great for installation. They're great for display. They're great for camouflage. They're great for mating purposes, sexual selection, things like that. There's lots of other things that could have given you feathers besides powered flight. And the modifications essentially of the hands and the shoulders, that's why you see this in the meat-eating dinosaurs, the theropods, because this is for essentially the grabbing essentially and cuddling, if you will, of the prey. Well, not cuddling. I'm not sure you'd call a velociraptor cuddling you, but grabbing the prey and not letting the prey go, essentially, as you see in such great scientific documentaries like Jurassic Park. But that type of motion, essentially, that's what gives you the reinforced clavicle that fuses and forms the furcula. That's why you see furculae in theropod dinosaurs. About the same time you see them in birds. That adaptation is very important for this kind of motion, for slashing and for grabbing and then dispatching the prey. And each of those modifications, I went through the lineage in class, and I'd like you to be able to have some of that lineage under your hat. Same thing with the whale. We talked about how you go from a vertebral column that supports the weight on land to now a vertebral column that's locked in the cervical vertebrae, but one now that just, you start to get simple vertebrae so that the body can undulate back and forth to swim. You get reduction of the hind limbs gradually, such that even modern whales have a pelvic girdle, but it's a shadow of its former self. You get the pelvic girdle that forms during embryogenesis, and then it recedes. You need that pelvic girdle essentially for the muscles because of the way muscles attach in the abdominal and appendicular cavities. So it forms and then it recedes, but the attachments stay. The forelimbs are modified to paddles. The bones very early get dense so that it can stay underwater. I didn't talk about this, but if you look at the mineral content of the bones, it's very clear that these animals went from freshwater to seawater relatively quickly. And to do that, you just need a kidney that can handle salt water. There are plenty of mammals that have kidneys that can handle salt water. That adaptation essentially is increasing the number of salt transporters in the kidney and making the nephrons of the kidney longer. You see that sort of arrangement in lots and lots of rodents. That's not an issue. To where you can get kangaroo rats at Mono Lake that can drink water that's brackish, that's 7 times saltier than seawater. And as you go from Mono Lake out, these animals can feed on saltier and saltier and saltier and saltier water until you get the kangaroo rats that can feed the salty water. So they're getting denser, they're being able to handle seawater. And then the modifications in the skull, where you get the bulla first, then you start to get that auditory cavity in the jaw that has a fat pad. The fat pad will be the thing that transmits the sound in the water. Sound transmits very, very effectively through the water relative to the air. So now the skull is going to be the thing that absorbs sound, and that will get transmitted to the ear. And we talked about those modifications. Pakicetus might have very well had Pakicetus almost certainly had, no, Pakicetus did, it had hind limbs, essentially. But Pakicetus still had the modifications for the ear. It's not fully aquatic yet, but it has the aquatic modifications in the ear. So that's so-called pre-adaptation. Then Ambulocetus, you see further reduction of the hind limbs. You're starting to see the hind limbs being detached from the vertebral column. And then Rhodocetus, you see it detached even more. And then Dorodon and Basilosaurus, now the body is even more elongated, and the pelvic girdle is gone in some species. And then the nasal cavities go from the end and then to here and then to the top of the head. You see that from Pakicetus, Ambulocetus, Rhodocetus, the nares are here, and then in Dorodon, it's up here. So those are all changes. The dentition goes from specialized to unspecialized, more just kind of nubby dentition. Yeah, so those are the anatomical features of again, you get these things, you don't get them all at once. You get a little bit here, a little bit there. Oh, it can do this. Because these other animals are still aquatic, but they're ambush predators. So they're essentially at water's edge, but they spend a lot of their time in water and what have you. So David Berlinski, who talks about the converting a Toyota Celica to a submarine, he says, well, that's an enormous engineering prospect. Well, again, he's making the mistake that you have to do it one thing at a time. If you do it one thing at a time, you get a creature that can't live on land or water. That's wrong. Clearly, that's wrong, because we have fossils that clearly lived on land and in water and were very successful. Did that answer your question, Josh? You did? Okay. Other questions?
For the different worldviews, should we know, aside from what they're about, should we know the big names attached to them?
No. I mean, Ham's name is pretty easy to remember. It's what you have for breakfast, or for Christmas. But I don't need you to know names of people. I'm more interested in the worldview, that you understand the worldview. That's what I want you to know. So you don't have to learn John Polkinghorne's name or what have you. I gave you those names because if you wanted to read further on that, you could go to the Answers in Genesis website and buy their books and look for names like Mortensen or Bodie Hodge or any of the other people at AIG. If you wanted to learn more about progressive creationism, you could go to Hugh Ross's website or the Discovery Institute website or what have you. It was more giving you places to go to read more about these folks because you might want to at some point in time. So no, I don't need you to know names of people. I saw a look of great appreciation on some of your faces. I don't know about you guys, I'm terrible with names. I had my brother's first church where he worked, the managerial pastor there, he could meet you once and he remembered your name. The guy was amazing with names. That's a gift. It's a gift that I don't have, that's for sure. I mean, you guys in class, I was still calling you by different names by the 5th week. So I'll still call Gary Nick and Nick Gary. So I'm terrible. More questions? Oh, look at this, it's sunny. Well, well, well. Who'd have thought? No more questions? Zoomers, do you have any questions? No? So the last test ended with the selection problems. So essentially, from after talking about selection, we talked a bit more about drift, the neutral theory, things like that. Concentrate more on the history of life. That's what I'll spend most of my time asking you questions about on the test, okay? And then the worldviews of the things we considered. So ancient life, that's what I'm most interested in. The Evo Devo stuff, I will only ask you very general questions about those. I won't ask you specific questions about the examples we dealt with. The stickleback fish or fruit flies or butterflies or worms or what have you. Okay? Is there a terrible draft off that window?
No, there's a ladybug still in the seat.
Ladybug on your seat, okay.
Not big on bugs personally.
Oh, okay. Take your shoe off and whack it. That'll work. My daughter used to call me on her phone and say, Dad, can you come up to my room and smash this bug? I get this call. I was like, oh, it's Stacy. She's just upstairs. Dad, I need your maleness to come up here and kill this bug. Oh, Addie, do you do that too to your dad?
Yeah, I do.
You do? Okay. It's not just my daughter, so.
I have a question.
Yeah, go ahead.
For the arrangement of the continents,
Mhm.
do we just know what times they should be like in different arrangements, or should we also know like the habitats?
The movement of continents influences populations of animals and plants. When you get continents that are together, you don't get provincial populations. The animals, because of migration, and they're migrating a lot because they're looking for water. The migrations of animals are going to tend to homogenize populations. When you start to get separation of land masses, now you start to get provincial populations, you get speciation of those populations. So the separation of continents, particularly during the Mesozoic, becomes important, as does transgressions. The seas covering large portions of land masses, because now you have this really remarkable radiation of aquatic life, and the terrestrial life is now restricted to smaller areas. And so you get animals that essentially move between these little islands, and you get a lot of competition, very intense competition between populations that can be important. So the major ones I'd like you to know and appreciate. The big one, of course, is Pangea, and then the splitting of Pangea, and then the landmass movements during the Cenozoic, because that isolated particular continents, because it isolated certain continents that established certain flora and fauna on those. The big ones being Australia and South America. You had this big radiation of marsupials on South America and Australia. And in Australia, a lot of your marsupials are still the dominant mammals. Not so with the South American marsupials. They died out. Turns out they were dying out by the time the land bridge was made. When the land bridge was made, placentals moved down into South America, and they pretty much dominated an already dying set of marsupials. The one group that came from South America up to here are the edentates, the so-called possums. Great contributors to the ecology of our world, possums. They make great roadkill. I shouldn't say that. Our cat, we had this big black cat. Now, possums are a lot bigger than a cat. You think if a cat tangles with a possum, possum's going to get the better end of it. This cat was mean, not to people, but if that cat got in a fight with somebody, it was no holds barred. I mean, it was like big time wrestling with cats. And this cat tangled with a small possum, and it won. We saw this dead possum out back, and it was all scratched up. And we said, Herman, the cat's name was Herman. Herman did that. So Herman would come in, he'd be all beat up. And I just say to myself, boy, Herman, I'd hate to see that other cat, because I'm sure that other cat looks 20 times worse than you. So that's my story about edentates, possums. Nick, you were sick for a bit. You were out for a bit. You caught up? Yeah. You told me you needed to catch up a bit. So, so nothing on your catching up that you have questions about? No. Okay. Okay. So yeah, I tried to follow the PowerPoints best I could and try not to go off field, which I have a tendency to do sometimes. Hey, Sam, you look like you're pondering something.
No, I was just looking over what I wrote.
Looking over what you wrote. Okay. Gary? Good. Luke? Good. And Randy, I know if you had a question, you'd pipe up. You're quite good at asking questions. Well, okay, if there are no more questions, then we will stop. All right. I will see you guys for the final on Friday.
Our final is at 10 or 8 to
8 to
10.
10. Mhm.
Will you send me another Zoom link for that?
I certainly will.
Okay, cool.
And Kylie, just keep me in the loop about your health situation. If you need to Zoom as well because you get quarantined, that's fine. I'm perfectly okay with that.
Okay, sounds good. I'll let you know.
All right. And I'll make sure you get the Zoom announcement as well. Okay?
Thank you.
All right. You're very welcome. Okay. Have a good week.